In the last few days, I put a few videos up about my configuration system that I'm working on. As a quick recap, it allows you to run configuration just on the configuration management, just on the CLI. Single files, they do all of the stuff that CM does. You know, it's your item potency, it's your subscribing and restarting machines just as other resources adapt. Very, very difficult to write shell scripts that can do this. But it's a full first class shell orientated configuration management system. I mentioned that I wanted to move this, it also has manifests, and you can see these are hierarchical data in there, so bringing in concepts from here. And ultimately, I want to put them on autonomous agents, which makes them massively distributed. And so I'll do a quick demo of the autonomous agent support. What I'm going to be doing is managing a software that I'm busy playing with called Garage. It's a S3 server. I want to replace Minio since it's now been archived, and we need something new. And so an autonomous agent is like a Kubernetes operator. Essentially, they run forever. It's a state machine, and they take care of all of your management of an application, installing it, rolling out new versions, changing configuration, reacting to changes, remediating any fixes, any problems. And it does that with a state machine. And Choria has such a state machine built in, and it's really easy to use and really easy to adapt to really anything. You can use it to manage any kind of, really anything with an API, anything you can run commands against. You can do HVACs, you can do sensors, you can do software, you can do all kinds of stuff with it. It is a truly generic operator framework that's very, very lightweight. So here we see a state machine that will manage my garage. It's going to start off in a configure state where it will do a key value fetch to get the latest configuration that it should run against. Once it's gotten that configuration successfully, it will fire a remediate event. This will move the machine into managed state where it will essentially apply the manifest. While applying the manifest, it will do so under the control of something called the governor. A governor allows only a certain number of similar activities on the entire network, and so my governor for this has a value of 1, and that is because Garage is quorum based, and so I can only have one of the machines at a time changing its configuration, restarting, etc., or upgrading and downgrading. And so by putting the managed state under governor control, it means I automatically get a rolling deployment. Any kind of time that I need to change to the machine, it'll automatically be done in a rolling manner. Once it's successfully managed, it moves into a health checks page where it will check all the configuration is healthy, check the service is healthy using monitoring commands. It may even do things like schedule regular maintenance like backups or compactions, etc. And if anything is out of the order, it fires a remediate event that puts us back in there. That's all the states that this machine can be in, and that describes a fully managed piece of software. Now let's look at how that actually looks. In a configuration. So I'll flip back and forth between the graphic there, but our initial state is configure. It's this guy over here. The remediate event can fire from configure or from check. So we can see it come from configure or check. That moves it into managed state. And here is the health check event that goes from managed to check. See, if managed to check. The only way to get to check is via manage and via that event. I have two other events in here. That's puts a machine into maintenance, just means it does nothing. So if you want to do work on the server, put the automation into maintenance mode. It doesn't step on your toes and just goes on with, let you do what you want to do. And when you're ready, you fire the resume event, continues managing. So what does it do? In the configure state, we have a watcher. Watchers are essentially pieces of execution that attaches to the machine and waits for it to be in certain states and then fire events. And so here I'm doing a key value fetch out of the garage key value bucket, and I'm fetching a key called configuration. And only when it's successful, do I fire the remediate. But also if I ever restart and there's no actual change coming in, it's already in the right state, it will also remediate then. In other words, at fresh start, if the data has already been fetched and is still accurate, it just moves along and continues to management. I'll show you the data in a second, but for now, just keep that in mind. Here's another key value fetch which happens during the check phase, and that will fire the remediate if ever the data changes. Not if the data is okay. If the data is okay, it will just stay there, steady state. If the data change, it's going to fire the remediate event, which brings us back into manage. Now in manage state, it's going to run a Choria Configuration Manager manifest. It's going to apply it, and it's going to do so under a governor called garage, which will limit this particular function to one at a time for the entire cluster. And you can make it 1 or 10 or whatever you want. This will actually do the change, and once there's been a change, it will fire the health check event, which is this guy over here who's been into check. And when I'm in check, I do a no-op manifest run, because that allows me to detect changes. I can run it very quick. I can do it concurrently across the network. Doesn't matter. There's no governor control. It's safe because nothing changes. But then when it determines something does change, now I move into the state where I do the rolling remediate or rolling configuration change update, etc. So we see it applies a manifest. Let's see how that looks. There we go. I define the data that's going to come into the thing, and I set some defaults, example.net. Yeah. Now, if I look at my data, we can see it's just a piece of JSON, and I just put it into garage configuration, which is the key that the automation is polling. And so that data will overwrite and merge with this data. And that means I can change things like the root domain. See. Here I just define some YAML reusable stuff. I create all the parent directories. I copy my binary out with the correct permissions. I copy my service file out. And you can see I read a file that I then template parse. Let's see, machine CCM. This is the service file, and same templates as what you're busy seeing here. So that's equivalent to a file resource doing a template and puppet. And again with the normal file, which is the configuration. And finally I start the service, which will restart if any of these two files have changed, and it has a health check command where it runs garage status. And if ever, when it started the service, it will only consider the service to have started successfully when the status command passes, and we'll give it 5 times to try. So it's a deeper check than systemd's status does, basically. Of course, systemd can do this also, but there's some benefits in doing the monitoring here, because I'm looking to pull out the monitoring metrics and all this kind of stuff and pass that on to Prometheus and places like that. But this is the entire manifest. This installs the binary, the files, the servers, everything. And the Choria Autonomous Agent will keep that running forever, and the state machine will forever health check it, remediate, the health check, remediate. So let's have a look. I have no garage stuff in here at present. Yeah. And if I copy the machine, yeah, it takes a little bit for Choria to pull its store of machines and activate the machine. But very soon indeed we will see. Yeah, actually, it's already there. It's already done. And if we look, the service is running, and I can do status. It's up and running. So we can see it's very quickly, very easy to get done. And if I stop the service, let's see, service garage stop. Remembering that it runs every 20 seconds, so a health checks, and then it triggers a remediate after that. So we can see this has already been triggered and remediated. And so let's do the same on these other machines. Okay. And very soon we will have the full cluster built. Now I have here, the manifest and the binaries and so forth and so on. Choria supports distributing those things over the network. So I can say through classification, essentially, which machines are supposed to be managing Garage. It will download this operator into the machine, onto the node, start it all up, etc. And I can do, all of the kind of distribution of configuration management logic and desired state across the network. Choria supports all of that kind of stuff already. Let's have a quick look at doing a change here. I will just change this file and we'll put it into the key value store. Now the machines will listen on the network for that change, and if we look at the YAML file, it's already been rolled out. This rollout happens very, very quickly. All the machines immediately notices that a change is due, and they will then, under government control, do a rolling restart. And so even as we were looking over here, you would have seen that these machines would have done one at a time, done the rolling restart. And so even that configuration change that I just rolled out, it was done in that manner because I've set the policy that says changes always has to happen, one at a time only. And so while the service restarted, quorum would have been kept. And I have the ability to interact with these autonomous machines, see their state, change their state, ask them to move into maintenance mode, all this kind of stuff over an RPC API. And yeah, so ultimately that's the end goal. I've run these autonomous agents on 7-figure node counts before, 5, 6, 7 autonomous agents per node. And so, they're very, very lightweight. If I go in here, for instance, let me just go, if I do Choria machine run, it just runs it locally. It doesn't even have any dependencies at this point. If we look, you can see it's really quite lightweight. Now I can compile all of this directory down to a single zero dependency binary that you can just run, and it will manage this thing with no dependencies. And I'm looking to add a mode of this that's kind of in between the shell and the full Choria control, where it just needs a standard NAT server or something that's very easy to run, or you can even use a SaaS service if you wish to use it that way. So really, really easy to gain these abilities and run really massively distributed autonomous agents doing configuration management. But as I previously mentioned, we're focusing on a single unit and how to automate and manage and control a single module essentially. So that's where I'm at. Interesting times, and I will do a deeper dive on this at the Configuration Manager camp in February in Ghent.